China is about to do what no country has ever done before: bring back rock and soil from Mars in a single, fully autonomous mission. It's called Tianwen-3, and it's already in motion, aiming to deliver answers about ancient life, water, and the planet's deep history. But there's more. With NASA's plans delayed and funding uncertain, the question now is, who will shape the future of Mars exploration? Tianwen-3 is shaping up to be a defining moment in space history, not just because of where it's going, but because of how it's planning to do it. China's ambitious Mars sample return mission is designed to collect and bring home Martian rock and soil in one tightly integrated operation. If successful, it would mark the first time any country has pulled off a full sample return from another planet. And the entire plan is already in motion. The mission is scheduled for launch in 2028 using two separate rockets. One will carry a lander with a sample collecting system, including a deep drill and a robotic drone. The second will carry an orbiter designed to rendezvous in Mars orbit and receive the samples. Once the lander touches down, it will operate for about a year on the Martian surface. The real innovation lies in its multi-tool collection system. It will scoop loose surface soil, drill 2 meters deep into the crust, and deploy a drone to retrieve samples from locations up to 100 meters away. The drone, equipped with a robotic arm, offers flexibility and precision, ideal for navigating uneven terrain and collecting from untouched areas. These samples will be sealed in a sterile capsule, launched back into orbit using the lander's ascent module, and docked with the orbiter. From there, the capsule begins its journey home to Earth, with an arrival targeted for 2031. The entire mission is designed to be self-contained, avoiding the delays and complexities of multi-phase missions seen in other programs. Compared to NASA's plan, which relies on multiple spacecraft, international partnerships, and a longer timeline, Tianwen-3's single-mission structure is faster and potentially more efficient. With prototypes already under construction and landing sites narrowed to 19 candidates, the mission is no longer just theoretical. China is not only aiming to be first, it's building a system that could set the standard for how future planetary missions are done. While China builds momentum with Tianwen-3, NASA's Mars sample return mission is facing a wall of challenges. The original plan, a collaboration with the European Space Agency, was built around the idea of retrieving core samples already collected by the Perseverance rover. That rover has been drilling and storing rock tubes in Jezero crater since early 2021. The samples are promising. Some may contain signs of ancient microbial life or preserve details about Mars' watery past. But returning them has become a budgetary and logistical nightmare. The price tag has ballooned to around $11 billion, and the return date has slipped to 2040, almost a full decade behind China's target. This timeline and cost estimate triggered concerns in Washington. The proposed 2026 federal budget includes language recommending the termination of the project altogether, citing its expense and long timeline. The justification? Future human missions to Mars could return better samples at a lower marginal cost. The problem with that reasoning is that it delays critical science. The data that could come from these samples would help determine whether Mars ever supported life, what conditions astronauts might face, and how safe it is to bring Martian material to Earth. These are not details that can wait until the 2040s. Scientists argue that robotic sample return is an essential precursor to human exploration, not a luxury. Some voices in government are trying to keep the dream alive. Senator Ted Cruz, for instance, has proposed legislation earmarking nearly $10 billion for Mars-focused programs, including a new Mars telecommunications orbiter to support both robotic and future crewed missions. But political support is divided, and the timeline to implement such proposals remains uncertain. It's easy to underestimate the importance of a few tubes of rock and soil, but the scientific payoff from Mars samples could be extraordinary. These aren't just geological curiosities. They are time capsules, preserving the story of another world that may once have been alive. China's Tianwen-3 is being engineered specifically to find that story and bring it back intact. The mission's top priority is to search for signs of life, whether fossilized microorganisms, organic molecules, or even chemical traces of past biological activity. These are things we can't confirm with orbiters or surface rovers alone. Only in Earth-based laboratories can we perform the ultra-sensitive, high-precision tests needed to detect such evidence. The second goal is to study Mars' habitability, how it changed over billions of years. That means analyzing soil chemistry, mineral composition, and isotopic ratios to see how water, atmosphere, and surface temperatures evolved. Understanding when and where Mars was habitable helps us model the origins of life, not just on Mars, but on Earth and possibly elsewhere in the cosmos. Tianwen-3 also seeks to reveal the planet's geological past. The samples may show signs of volcanic activity, sediment layering, and magnetic field shifts. This kind of data could fill in huge gaps in our understanding of Mars' inner workings and its relationship to Earth's planetary evolution. The deep drilling capability is especially important. Most Martian missions have only scratched the surface, literally. By drilling 2 meters down, Tianwen-3 can access layers that have been shielded from radiation and environmental damage, possibly preserving complex organic molecules or ancient climate records. This race isn't just about who touches Mars, it's about who brings it home. China's Tianwen-3 is rapidly becoming a symbol of scientific ambition, technological precision, and international outreach. With NASA's plans uncertain, the mission could define the next era of planetary exploration. And whether those first Martian rocks are stamped, made in China or USA, their impact will reshape our understanding of life, the universe, and our place in it. The journey is just beginning, and the countdown to Mars sample return is already underway. To dive deeper, click the link to watch our full video and don't forget to like, share, and subscribe. Thank you for watching. See you there.